The practice of developing and using models is one of the key practices identified in the K-12 framework and the Next Generation Science Standards as central to scientific reasoning. The Amplify cell biology module was designed to teach this practice. Developing and using models is the key intellectual work that grounds the unit and gives it the potential to be a powerful learning experience. Sometimes when we think of models in science, and especially in the science classroom, we tend to picture actual objects like styrofoam balls depicting the solar system, or plastic torsos showing human anatomy. And in the case of cell biology, we often talk about and refer to cell models. Perhaps in the past you may have had your students build physical depictions of cells as part of your own cell biology unit. These kinds of representations can be very useful in the classroom and help students envision things that are not accessible to direct observation. But the practice of developing and using models, as highlighted in NGSS and in the Amplify cell biology unit, takes this a step further and focuses on developing conceptual models that can be used to explain how or why things happen in the natural world. A model in this sense is so much more than an image or depiction of what something looks like. It's a way to be explicit about the parts of a system and how those parts interact to produce observable phenomena in the world. These kinds of models are dynamic things. They allow you to run through processes and think through what affects what in the system. Whether these ideas are shown as 3D styrofoam shapes, a drawing on a piece of paper, a paragraph, or a computer animation, the important thing to focus on is the underlying idea of how the system works. It is not modeling if you merely tell the students the name of this thing and the function of another thing. It becomes modeling when the students work to figure out how the system works with the purpose of explaining a broader phenomenon in the world. This is not learning the parts of a cell for their own sake. Instead, it's about figuring out how each component works within the broader system and how the interactions between and among the various parts allow you to understand the whole business. So knowing that a mitochondria is the powerhouse of the cell does you little good if you don't understand where that power is coming from and what it fuels.
I never learned this before, so it helped me learn what happens in the cells and what's in myself.
Modeling is about making students agents of their own learning by presenting them with something to explain. In this case, they are trying to figure out the connections between the cell and the organism function by focusing on the phenomena of eating and breathing. They're interacting with the simulation to figure out how it works. So the model in this case is not the simulation itself, but think of the model as the underlying rules of the system. It is these rules that the students are trying to uncover and be explicit about, and they can do this by interacting with the sim in particular ways.